having so much trouble with this problem.
Yeah, me too. See, the pressure here, I'm not really sure what it's supposed to be.
Yeah, I don't know. I got to that part, but I just was confused.
Yeah. Let me see how you worked on yours.
Yeah. See, I got it
Okay,
there.
yeah. It's just not coming together.
No, I don't know.
Don't worry, I'll help you.
Yeah!
Alright, so problem 2.58. You start off with this picture where you have basically a container in some liquid. It has a hinge. We'll call this point A, where the hinge is. It has a hatch that's oriented 30 degrees from the horizontal. As shown to the point where the hinge is, it's 10 meters. Above it you have seawater, the free surface, and then inside here you have air pressure. What they want you to figure out is the minimum pressure P1 that will open the hatch. Essentially what they're asking for is when the moments about point A will be 0, which will allow the hatch to swing freely and swing open. And the problem tells us to neglect the weight of the hatch and the friction in the hinge. So from this diagram, you can obtain this. 10 meters you know. From there, you know this angle is 30 degrees. Then here's the centroid at the center of the object. Orienting your axis like this with the y in this direction and the x in this direction, you have yc traveling to the centroid of the object, which is where P1A acts, which gives you the force due to the pressure acting through the centroid of the object. You also have Fr, which is the resultant force of the pressure distribution of the water acting on the hinge. And then you have Yr, which is the distance that it is away using this year origin along the y-axis. You also put this in there, Hc, which is the height vertically in our original coordinate system to the centroid of the object. This leaves us with the unknowns. Hc, Fr, A, P1A, Yr, and Yc. So starting with Hc, if you know that this is 10 meters, and you know that from here to here is 2, then to figure out Hc, you need to find the vertical distance from this point to the centroid, and then add it to 10. So to obtain Hc, it's going to be your 10 meters plus 1 meter sine 30 degrees, which gives you 10.5 meters. From there, we'll move on to Fr. Fr equals the specific weight of seawater, which, if you get from the book, is kilonewtons per meter cubed. So gamma seawater times Hc times A. So also solve for A in here. You know that gamma seawater, as given there, we'll put that as 101 10 to the third newtons per meter cubed times the Hc, which is 10.5 meters, times A, which is pi r squared. Since we have a 2 meter diameter hatch, then pi r squared is just going to be pi times 1 squared, which is just pi. And this will give us Fr. Fr is 333.166 newtons. So our unknowns, we have this, that, that. So now we need P1A, Y, and YC. P1A we'll solve for at the end. So let's move on to YR and YC. Alright, the equation for YR is given as YR equals YC plus IXC. You know it's the moment of inertia about the x-axis. because it's right there, and if this hinge is going to rotate, it's going to rotate about that axis when it swings up at the hinge at A. So I mean, from a circle, no matter where you orient it, it's going to be the same, but that's how you know it's about that axis. Then YC times A. So for this, we need to know YC. So YC will basically, is the hypotenuse of the triangle that's formed by HC and this sine 30. So knowing that sine 30 is going to be HC divided by YC, then HC divided by sine 30 will give you YC. So we know HC is 10.5 meters. So Y equals 10.5 meters. That's our HC divided by sine 30, which is equal to 21 meters. All right, so now we know all the components of that except IXC, which is equal to pi r4 divided by 4. Once again, our radius is just 1, so that ends up being pi over 4 meters to the 4th. Yeah. So we plug our IXC that we obtained, the YC, and then we know the A to be pi. It's in meters squared. So this is equal, the whole thing, to YC, which is 21, plus IXC, that is pi over 4, divided by YC again. And then A, which is pi. So this is in meters, this is in meters cubed, meters squared, you end up with meters and meters. This ends up being 21.012 meters. Then all you really have to do is plug it in to equal, get that NA equal to 0. So you need two distances. You know P1A acts at a distance which is equal to the radius from point A. Then you have FR, which will act at a distance of YR minus the distance from the hinge to the surface of the water. So you obtain that, you know FR will be acting in a positive sense, trying to turn it, so times YR minus 10 sine 30, which is the distance from the surface to the hinge at A, minus P1A times 1 meter, equal to 0. And this whole thing is summing moments about A equals 0. From here you know FR, you put them on opposite sides, so it ends up being FR times YR minus 10 sine 30, all divided by A is equal to P1, once you put that on the other side, and then divided by A. So knowing these values, you get 3 minus 10 sine 30, all divided by pi. Alright, from there calculating that, we get 107.5 kPa, which is your answer.
Thanks so much, Professor Hardesty.